Hello everyone. In continuation with our assignment problem, in this video we'll see when do we go for arbitrary assignments and what will be the result based on arbitrary assignments, right? So consider the following data regarding the time involved in hours for various combinations of jobs. Jobs are A, B, C and machines W, X, Y, Z. These are the machines, these are the jobs. Find the optimal assignment schedule which will minimize the total time. So first thing is, this is an unbalanced assignment problem since number of rows are not equal to number of columns. So that means we need to bring in one dummy row or a dummy job we have to bring in. So first of all, we'll create the balanced matrix A, B, C, and then a dummy job, then W, X, Y, Z. We know if there is a dummy, then the cell entries corresponding to that will become zeros because it is only a dummy being created just to apply the algorithm. So 8, 13, 17, 19, 10, 15, 19, 22, and this will be 0, 0, 0, and 0. What is this? This is a balanced AB. Okay. Now, what is the first step? Row minima reduction. I mean, you can, one more thing is, after you check whether the problem is balanced or not, you convert that into balanced. You need to see whether the cell entries are based on the cell entries, is it a minimization or a maximization? Since it is related to time in hours, our objective will be to minimize only. So no need to do any conversion. If it is a maximization, then only you require to do some conversion, otherwise not required. So row minima reduction will be our next step. What is that? Each row you identify the least. First row, the least is 18. Subtract all these elements with 18. So 18 minus 18, 0. 24 minus 18, 6. 28 minus 18, 10. 32 minus 18, 14. Then least is 8. So 8 minus 8 is 0. 13 minus 8 is 5. 17 minus 8 is 9. 19 minus 8 is 11. Here the least is 10. So 10 minus 10 is 0. 15 minus 10 is 5. 19 minus 10 is 9. 22 minus 10 is 12. Last row anyway, it has got already zeros. Actually, the next step is to do a column reduction, column minima reduction, but that is not required because every column has already got a 0 in it. So straight away we can go for assignment step. Means you will review each row to check whether the presence of single 0 is there or not. If it is there, you will assign it. Otherwise, you will ignore that row and move on to the next row. First row, does it have a single 0? Yes, assign it. Once I do an assignment in a row, then in the corresponding column, wherever you assign in the corresponding column, any other zeros present are to be crossed. So we are going to cross these. Then move on to the second row. There is no 0 now. Third row, there is no 0 now. Fourth row, more than single 0, you have to ignore all this. Now coming back to column reviews. First column already assignment is done. Second column, single 0 is present. Yes, assign it. Now that I assigned this, any 0 present in the corresponding row, any other 0 present in the corresponding row needs to be crossed. So I need to cross this, cross this. Third column, there is no 0 present. Fourth column, there is no 0 present. Once again, review row. First row already assigned. Second row, there is no 0 present. Third row, there is no 0 present. Last row already assigned. Now, the next step is to tick all unassigned rows. This row is unassigned. This row is unassigned. If a row is ticked and if it has or had a 0 in it, tick the corresponding column. It had a 0 in it, tick the corresponding column. This had a 0 in it, tick the corresponding column. A column is ticked, and if it has an assignment, tick the corresponding row. Again, repeat. Row is ticked, has a 0, tick the corresponding column. Row is ticked, had a 0, tick the corresponding column. Row is ticked, had a 0, tick the corresponding column. Column is ticked, has an assignment, tick the corresponding row. No more ticking is possible. Next step is draw lines through unticked rows, unticked columns. The last row is unticked, so you have to draw the lines through that. Then unticked, draw lines through unticked rows and ticked columns. That means the first column needs to be ticked. I'm sorry. Draw lines through unticked rows and ticked columns. So I have to draw a line through the first column. Now we may notice that the number of lines we could draw is 2, and we had 2 assignments. It is matching. Now we have to identify what is the theta. Theta is the least value where lines are not passing through. 6, 10, 14, 5, 9, 11, 5, 9, 12. Least is 5. So what is the step? Wherever single line is passing, you need to retain the same elements. Wherever 2 lines are passing, you need to add the theta value. Wherever no line is passing, you need to subtract the theta value. Based on that, we will create a new matrix. First one, this 0, single line passing, retain. Next is 6, no line is passing, you have to subtract theta. Here subtract, here subtract. Single line, retain, retain. 2 lines, add. Here subtract, subtract, retain. Subtract, subtract, retain. Subtract, subtract, retain. So for this new matrix, we need to check for the assignments once again. So first row, does it have a single 0? Yes, assign it. Since I assigned here, any other 0 present in the corresponding column needs to be crossed. So I'm crossing this, crossing this. Second row, does it have a single 0? Yes, assign it. Since I assigned it here, any other 0 present in the corresponding column needs to be crossed. So I'm crossing this, crossing this. Then third row, it doesn't have a 0. Last row, it has got more than 1 0. You have to ignore both these rows. Coming to column reviews, first column already assigned, second column already assigned, third column, does it have a single 0? Yes, assign it. Since I assigned that, any other 0 present in the corresponding row needs to be crossed. So I'm crossing this. Last column, it don't have any 0. Now go back to row reviews. First row already assigned, second row already assigned, third row do not have any 0 to assign, last row already assigned. So no more assignments are possible. Still, we got only 3 assignments, whereas our desirable number of assignments is 4 because this is a 4 by 4 matrix. Okay, what is the next step? Tick all unassigned rows. If a row is ticked and if it has or had a 0 in it, it had a 0, it had a 0, tick the corresponding columns. If a column is ticked and if it has an assignment, tick the corresponding row. If a column is ticked and has an assignment, tick the corresponding row. Then draw lines, once again, check if a row is ticked, has a 0, tick the corresponding column. Row is ticked, has a 0, tick the corresponding column. Row is ticked, had a 0, tick the corresponding column. Column is ticked, has an assignment, tick the corresponding row. Has an assignment, tick the corresponding. No more ticking is possible. Draw lines through unticked rows. And ticked columns. Identify theta, which is the least element. Here theta, you may notice it is 4 because 4 is the least. Now form a new matrix. Wherever single line is passing through, retain the elements 0, 0, 0, 1, 0, 0, here 0, 0. Wherever two lines are passing, add theta. So 5 will become now 9. This 0 will become now 4. Wherever no line is passing through, subtract theta. That means this will become 1. This will become 5. This will be 0. This will become 2. This will be 0. This will become 3. Now, restart our assignments. First row, does it have a single 0? Yes, assign it. Now, since I assigned it here, any 0 present in the corresponding column needs to be crossed. So I'll cross this, cross this. Second row, does it have a single 0? No. Ignore for the time being. Third row, more than 1 0, ignore for the time being. Last row, more than 1 0, ignore for the time being. Now, coming back to column review, first column already assigned, second column more than 1 0, third column more than 1 0, last column, yes, it has got a single 0, assign it. Since I assigned here in this column, the corresponding row, if any 0 is there, you need to cross. So this 0 has to be crossed. Okay. Now come back to row reviews. First row already assigned. Second row more than 1 0. Third row more than 1 0. Last row already assigned. Column. First column already assigned. Second column more than 1 0. Third column more than 1 0. Last column already assigned. Now, what is the next step? Tick all unassigned rows. If a row is ticked and if it has or had a 0 in it, tick the corresponding column. So this. Why? Because it had a 0, I ticked the column. It has a 0, I ticked the column. It has a 0, I ticked the column. Then again here, row is ticked, had a 0, tick the corresponding column. Has a 0, has a 0. So those columns are ticked. If a column is ticked and if it has an assignment, tick the corresponding row. A column is ticked, no assignment. A column is ticked, no assignment. So no more ticking is possible. Now, once again, this row is ticked, has a 0, tick the corresponding column. Yes. No more ticking is possible. Draw lines through unticked rows. Only one row is unticked. And ticked columns. There are 3 columns which are ticked. So I need to draw lines through that. Here we may note that the number of lines we could draw, we could draw is 4, and that indicates 4 assignments possible at this juncture. But we had only done 2 assignments. That means we can do arbitrary selection of zeros. We'll understand this in the next table about whatever I wrote here. Now, let me write the numbers 0, 1, 1, 5. 0, 1, 1, 5. And then 0, 0, 0, 2. Then third row, 0, 0, 0, 3. Last row, 9, 4, 0, 0. Right. So where we did assignments, this assignment and this assignment. So I'll just put a box there. once you do an assignment, any other 0 present in the corresponding row or column needs to be crossed. So I need to cross this, cross this. Similarly here, I need to cross this 0. Any other 0 present in the corresponding row or column needs to be crossed. Now, let us go to row 2. There are two zeros. Let us arbitrarily choose any one 0. Choosing arbitrarily X is denoted for the assignment. X, which one I will be choosing? Second row, second column for assignment. Means I'm going to choose this for assignment. Second row, second column. This is second row, second column. If I assign this, any other 0 present in the corresponding row and column needs to be crossed. So I'll have to cross this, cross this. Now coming to the third row, is there a single 0? Yes, we assign it. So this is one optimal solution. Let me write the optimal solution here. We know this one is job A, job B, job C, and this is a dummy job. This one is machine W, machine X, machine Y, machine Z. So I'll say assignment job A is assigned to machine W. Why? Because box is there. Job B is assigned to, box is here, that means B is assigned to machine X. Job C is assigned to machine Y. Dummy job is assigned to machine Z. And what is the time in hours? That we have to refer from the original matrix A to W. A to W is 18. Then B to X is 30. A to W is 18. B to X is 13. And then we may refer to the original table. C to Y is 19. Dummy, of course, it is 0. Now, if you add, we will get the least time possible. 9, 3, 12. This becomes 20. And this is 50. So 50 hours is the minimum time or minimized time or least time. Now, in this, we arbitrarily had chosen X double 2. What will happen if you choose something else? We'll do that also. Let me choose. Yeah. Let us choose A, B, C, D, W. Let me put line here because that solution is for that. I'm just putting here Y, Z. It is 0, 1, 1, 5, 0, 0, 0, 2, 0, 0, 0, 3, 9, 4, 0. Now, we know initially we assigned this and we assigned this. Since we assigned this, any 0 present in the corresponding column needs to be crossed. Here, any 0 present in the corresponding row or column needs to be crossed. So I crossed this. Now, that time we had chosen initially X double 2 for assignment. Now we will choosing arbitrarily X 2, 3 for assignment. Then what happens? I am choosing this 2 and 3 means row position is 2, column position is 3. That means I should cross any other 0 present in the corresponding row and column needs to be crossed. Now, if I come to the third row, this becomes single 0. So assign it. Now let us see what is this is also an optimal solution. Since this is an optimal solution, again, you call it as alternative or alternate optimal solution. Alternate optimal solution means assignments may be different, but the minimum time will be the same. We'll see that. Assignment should be the same. And then time in hours. First assignment A to W. Second assignment B to Y. Third one C to X. And then dummy to Z. Now going back to the original matrix to refer what is A to W. A to W from the original matrix, the time given is 18. B to Y, the time given is 17. C to X, time given is 15. Dummy to Z is 0. Again, calculate this. 7 plus 5, 12. 12 plus 2, 12 plus 8, 20. So it becomes 50. So even though the assignments are different, here it is B to X, here it is B to Y, here it is C to Y, here it is C to X, but the total time taken is 50 only. So that is why it is an alternate optimal solution. So arbitrary selections are possible only when your number of lines we could draw matches the number of assignments. Means here it was 2 assignments, but we could draw on 4 lines. So it made us to do the arbitrary selection. Otherwise you can't. Otherwise you have to repeat the process one again and again. But here we could already, we are already able to draw 4 lines. That means 4 assignments are possible. On that basis, we could do the arbitrary selection of assignments, right? So that is the solution for this particular problem. In case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you.